new electrothermal energy based non-conventional machining process. That is plasma arc machining, or it is popular as a plasma arc welding. Okay. Now, if you see the name now, then what is the name? Plasma arc machining. Okay. So whenever we heard the word that plasma arc machining or the plasma arc machining welding, then we first think about the what is plasma. Plasma means what? Okay, that basic question arises in our mind. No? So let us have a close look at what is that plasma. Okay, what is that plasma?
हॅलो. हा, आवाज येतोय ना? हा, आवाज येतोय ना? ओके.
Okay.
सो हा, ओके, मोबाईल थ्रू कनेक्ट झाला. So firstly, I will tell about the plasma means what. Okay, I repeat once again, this plasma combustion process, it is popular in the field of welding. So plasma arc welding, okay, this machine is famous. So we'll start with the plasma. So as we know that when a gas or air heated at a high temperature, okay, when gas or our uh, air heated at a high temperature, then the number of collisions between their atoms will increase. Okay, as we studied in the physics now, when we hit the any molecules or gas molecule or the air molecule heated at a very high temperature, no, then number of collisions between their atom it increases. And when you hit the gas about 500 5,500 5,500 degrees Celsius, no? Then it partially ionizes into the positive ions. Okay, whatever your heated gas molecules or whatever heated air molecules are there, no? So then it start ionizing, that it partially ionizes into their positive ions and negative ions, and third one is the neutral ions. Okay, आपल्याला माहित आहे मॉलिक्युलचे 3 आयन्स तयार होतात ना, so ionization. So that ionization, okay, that partially ionizes into the 3 parts. One is the positive ions, negative ions, and neutral ions. And when you further heat the gas, okay, if again further will heat that gas, no, above the 11,000 degrees Celsius temperature, then what happens? It completely ionizes. It completely ionizes, and such completely ionized gas is called plasma. Okay, I repeat, such a completely ionized gas is called the plasma. And plasma state lies in between. Okay, plasma state is that heated state, no? So that plasma state lies in between temperatures 11,000 degrees Celsius to 28,000 degrees Celsius. So that much temperature, if your gas will actually, no, then you will get that plasma. Okay. Now, normal gas, you can take any gas or the air. That, I repeat once again, that gas or air you have to heat. Okay, up to 5,500 degrees Celsius. At that time, your gas or that air will partially ionize into the positive ions, negative ions, and neutral ions. And again, if you further go for the heating of that gas or air above the 11,000 degrees Celsius, then it completely ionizes. and such a completely ionized gas is called plasma. Okay, and normally this plasma state lies between the temperature range 11,000 degrees Celsius to 28,000 degrees Celsius. Okay, this is about the basic plasma means what that we should know. Now, quickly, I will just uh, within two lines, I will tell about this plasma arc machining also, and then we'll go in detail. So, start with the introduction. Okay, now another question. Just I have given the answer about the what is plasma. Then basic question will arise: what is plasma arc machining? Then, so basically, this plasma arc machining, in short, PAM, is a metal cutting process. Okay, because it is uh, famous in that field. Plasma arc machining is the cutting, and the plasma arc welding again is there. So this plasma arc machining is a metal cutting process where metal are cut. Okay, metal are cut with plasma arc. Okay, or a tungsten inert gas arc or a torch. Okay, metal is metals are cut with plasma arc or tungsten inert gas arc or a torch. It is mostly used for the metal that cannot be cut by oxyacetylene torch. काय आपल्याला माहिती आहे आपण गॅस वेल्डिंग कधी कधी मेटल कट करतो. So in that cutting, no, we were in traditional way. If you compare, no, then oxyacetylene torch is used. So the metal which are not possible to cut using the oxyacetylene torch, no, so that time you can go for this plasma arc machining. Okay, again, do you know when this plasma machining was introduced? Okay, when this plasma arc machining was introduced. So well, plasma arc machining was introduced in the industries in 1964. Just I'm going for the history part. So 1964, in that year, this plasma arc machining firstly introduced as a method that would help in the arc welding. Okay, ट्रॅडिशनल म्हणजे कन्व्हेन्शनल आपल्याला मशीनिंग प्रोसेसमध्ये आपल्याला वेल्डिंग आहेत ना वेगवेगळ्या वेल्डिंग. सो फॉर द सेम पर्पज दिस प्लाझ्मा आर्क मशीनिंग introduced in the industries in the 1964 as a method that would help in the arc welding, and that would require less current supply also. Okay, so this plasma arc welding, already I just told that is referred as a PAM, capital PAM. So in this plasma arc machining, different gases are used according to different materials. Okay, कुठलं मटेरियल आपल्याला कट करायचंय, okay, त्यानुसार तुम्ही ते प्लाझ्मा आर्कचा गॅस जे आहे that you can select. So here different gases are used according to your different materials, and different materials means what? That your workpiece, no? So your workpiece may be made up of aluminum or iron or steel. For example, for aluminum uh, is your workpiece. Then that time nitrogen gas is used for this your plasma arc machining purpose. Okay, so your as I mentioned, your workpiece material maybe your aluminum, iron, or steel. Okay, depending on that, you have to select your that different gas. Okay, again for argon, okay, hydrogen is used. Okay, again in most of cases, nitrogen and hydrogens are used as a gas, inert gas. Okay, for that generation of the plasma. Okay, so nitrogen and this hydrogens are used. Again, this plasma arc welding, it employs a very high velocity jet of high temperature gas. Okay, I repeat, plasma arc welding. Okay, in general we are studying the plasma arc machining, but the plasma arc, this machining particularly early used for the welding or the cutting purpose. So if you consider the plasma arc welding, so that you can employ so in that you can employ very high velocity jet of high temperature gas for what purpose? To melt and display a material in its that path. Okay, so this is a basic idea about the plasma arc machine. Okay, now come to the our PPT. Okay, so today we are going to see in detail, we are going to discuss this plasma arc machining process. And just I told about the what is meant by plasma. So all of you know that plasma. Okay, so generally this gas molecule. Okay, once again I repeat, as we know that generally this gas molecules, it consists of 2 to 3 atoms. Okay, so when these atoms, sorry, these molecules or gas molecules is heated up to a very high temperature. Okay, very high temperature. Suppose around 2000 degrees Celsius. Okay, 2000 degree centigrade. So these atoms of the gas molecules actually from that your molecules are separated out, and when these atoms are heated up to again to very high temperature, maybe around 3000 degrees centigrade. So that time these electrons and the ions, that means the positive ions, negative ions, and nuclear ions of that your molecules are actually dissociate from the atoms. Okay, so that more collisions will happen, no? So that will dissociate from the atoms. Okay, so a gas is heated of more than 2000 degrees Celsius molecule, then molecules separated out as a atom. So having the gas is having 2 to 3 or more than that atoms, okay, at that 3000 degrees Celsius temperature, or more than more the your electron will dissociate from the atoms. And now dissociation means what? Your gas, that atoms will ionized. Okay, and it will consist of the ions, that means the positive ions, negative ions, that means the electrons and the neutrons. So हॅलो, हा सॉरी, लाईट कॉलेजमध्ये गेल्यामुळे जरा प्रॉब्लेम झालाय. आता आवाज येतोय? हॅलो, आवाज येतोय का? Hello. हॅलो. हा, एक मिनिट, मोबाईल थ्रूच नेट. Okay. Ha. So I was discussing about the this. So if your temperature of molecules will go beyond the or at 3000 degrees Celsius or that more, then your electrons will dissociate from the atoms and then it will ionize. Okay, and the ionization means what? It will consist of the ions and the electrons. So that state of your gas is called the plasma. Now, what are the characteristics of this plasma? Okay, so that glowing, then ionized gas. So it will result from the normally heating of your metal to extremely high temperature. Okay, so again that plasma it normally composed of the free electrons, no, so which are dissociated from the your gas atoms, main gas atoms. Okay, again a gas in the plasma state become the normally that electrically conductive as well as the responsible to your magnetism also. Okay, so according to fourth state of matter. Okay, and plasma normally this plasma is encountered in a electrical discharges. Okay, now let us have the look on that working principle. Okay, so normally we need a heat generation source. Okay, in the your plasma, and then by heating, by supplying the heat to that gas, you will get the plasma. So it will that your molecules will ionized. Okay, and you will get the that ions and the electrons. Okay, correct, that means positive, negative and neutral. Okay, and that means that your plasma. Then that plasma you can use, okay, having the temperature more than 3000 degrees Celsius. Okay, so that you can use for the any cutting of any metal, including those having the high thermal conductivity and the large heat capacity or good oxidation or resistance, like stainless steel or the aluminum. So for that material, you can to cutting that material, so we can use the plasma. Okay, but here whatever the workpiece material, okay, which are not possible to cut using the conventional methods, no, So that material we can easily cut, or you can go for the machining of that material using this plasma arc machining. Okay. So this you can see this diagram now. So we'll have the gas. Okay. And then to heat that gas, we require the electrical current or electrical supply. So for that purpose, your workpiece will act as an anode, and you can give that your electrode. Okay, whatever the tungsten electrodes is there, no. So that will act as a cathode. Then you will get the gas. That gas will give the plasma arc, correct, by hitting that molecules. And then that plasma arc we can use for the cutting or the welding or the machining operation of the on your any type of work material. Okay, so this is simple diagram. Now whatever your electrodes are used, now here normally tungsten electrodes are used. Okay, and gas. Okay, so gas normally hydrogen, maybe nitrogen. Okay, depending on that gas, your plasma arc will generate. Again, the selection of the gas will depend on the your workpiece material. Okay, now, so I will give 5 minutes. So please draw this diagram. Please draw this diagram. Draw this diagram. Where the diagram is visible about the other that elements that I am going to talk. Don't worry in the system part. What is that role of the spreading gas? Right. That I'm going to talk. Don't worry. Okay. Now for working principle, you can write down these steps also. Okay. How does that source of heating in plasma? Then when uh, these are separated atoms, okay, and the electrons, that means separated ions, and also these atoms, oh sorry, that electrons are going to recombine, okay, they recombine, no? So this recombination of atoms liberate energy. So for that one energy, that liberation, no? So that bonding energy is responsible for to increase the kinetic energy of that atom or that molecules which are formed by the due to the recombination. So due to the recombination of these electrons and ions into the that and atoms, and these atoms because of bonding energy, okay, or because of this recombination of these ions and the electrons into the atoms, okay, into the molecules. So because of this liberated bonding energy, huge amount of heat, due to that bonding energy, huge amount of heat is generated. Okay, so this because of liberated bonding energy, which is responsible for the increased kinetic energy of these atoms and the molecules, which are formed for due to the recombination. So temperature is generated around 33,000 degrees centigrade also. So this kind of heat is generated. So that is why the temperature rises up to the 33,000 degrees centigrade. Okay, well, you can go in detail again and again. Okay, so because of this increasing of the temperature, no, huge amount of energy is generated, and this much of heat can be used for the any cutting purpose, for any kind of cutting purpose. So which is the material which is not possible to cut by using the oxyfuel cutting, or oxyfuel gas cutting, you can use this plasma cutting for that material. So that kind of thick thick metal can be cut by this plasma cutting process. So you can cut any kind of metal, including those having the high thermal conductivity, high heat capacity, and the good oxidation resistance. So temperature, this much of temperature is useful, helpful for cutting any kind of material having high temperature, that your thermal conductivity, then a larger heat capacity and good oxidation resistance. Okay, again material like aluminum, then copper and stainless steel can be cut or can be machined using this plasma cutting or machining. So this kind of material with higher thickness can be cut by using this process. Okay, which is not possible using your conventional method like oxy fuel cutting. So normally, what are your conventional machining process are, so it's having some limitations. So that limitations we can overcome by using this plasma arc cutting or the plasma arc machining process. Okay. Now talking about this diagram. Okay, this. So we can see in the diagram also. So as we give the power supply to that system now, an electric arc will develop between the cathodic tungsten electrode and the anodic nozzle. Okay, I repeat, the electric arc will develop between the cathodic tungsten electrode and the your that anodic nozzle. Okay, and as the gas comes in contact with that your with the plasma, no, then there is a collision between the atoms of the gas and the electrons of the your electric arc, and as a result we get the ionized gas. ओके, त्या टंगस्टनच्या टंगस्टन इलेक्ट्रोड आहे त्याच्या कॉन्टॅक्ट मध्ये तुमचा प्लाझ्मा गॅस आला. ओके, देन दॅट आयोनायझेशन विल start. Okay, and then there is a collision between that your atoms of your gas and the electrons of the electric arc. Okay, that means you will get the ionized gas, and that means that we get the plasma state. Okay, and that we wanted for the your our plasma machine. Okay, now this plasma is targeted. What are you are getting that red color? No, that plasma is targeted towards your workpiece. Okay, with a high velocity and the machining process. Okay, with high velocity to flow to your workpiece, then the machining will start. And one thing to be noted down is that your high potential difference is applied between that to get plasma state. Okay, you can for purpose DC power supply used. Okay, so in this whole process, no, high temperature condition is important. So that high temperature condition are required. Okay, how gases comes out of that nozzle. So the chances of the overheating. In order to that overheating, to prevent that overheating, so water jacket and that shield gas nozzle. So other that shielding gas we have to use. Getting or not? How that plasma arc is generated? Okay, for what? How we can give the heating and how we can use this plasma cutting purpose? Just I will show that plasma arc. 1 minute. So that tungsten electrodes we are using, that is non-consumable. Okay. And we are giving the power supply by connecting the negative terminal to the that electrode and the positive terminal to the workpiece. Okay. And to prevent from the overheating, we have to use that cleaning gas and water cooler restriction nozzle. Okay. And when your plasma gas will come in contact with your that tungsten electrode, no, then that due to heating, there will be the collision will happen between the ions of the gas and the electrodes of the that rod, and you will get the plasma arc. And then you can use that plasma arc for cutting or the machining or the welding purpose. Now to generate that sheet, no, we have to uh, go for the you can see one application also. This is a CNC plasma cutting machine. Once again, I repeat, give the heat to your that plasma gas. No, we require some heating medium or heating element. So that tungsten electrodes are used. Okay. So due to that heating, no, that molecules of the your gas is going to separate out as atoms. Okay, and that atoms again into the your ions. Okay, up to if your temperature is increased below the again sorry above the 3000. So that time you will get that positive ions, negative ions, and neutral. Okay, so and so that some from that atom, some atoms will get dissociate, and the gas becomes the ionized, which is consists of the ions and the electrons. So that state of the your gas is called the plasma. Okay. So don't forget that the temperature of that plasma can be of the order of 33 um, 1000 degrees Celsius. And when such a high temperature source react with any workpiece material, no, then workpiece material get melt out, and maybe sometime even vaporize, and finally it cut into the pieces. So many metals say aluminum, stainless steel, having the high temperature conductivity, high heat capacity, or the good absorption resistance, that can be cut, or that can be machined using this process. And as a result, such metals cannot be cut by the conventional techniques like oxyfuel cutting. But these that types of, or that kinds of the materials can be easily cut by using this plasma arc machining or plasma arc cutting method. For any electrothermal energy based process, no, that material removal will take place due to that melting and the vaporization, okay, due to that heating, no, to high temperature. So if you take example of the your EDM process, or that electro discharge machining, or electron beam machining, or the laser beam machining, or this plasma arc machining also, for each and every process the melting and the vaporization is taking place due to the temperature, the heat energy, okay. Now this is a plasma arc welding process. So plasma gas, maybe argon or hydrogen, okay, we can use. But electrode is non-consumable, that tungsten. Don't forget. One minute. Just a read because voice is constant. As I have mentioned that concept of removal matter. So here thermal, that heat energy is required. So it is thermal energy process. And to cut, we require the high velocity jet of your high temperature plasma. So due to that sliding nozzle, you can easily uh, target your workpiece. Okay, so in that small region, through that region only you can through your plasma gas, through your plasma gas. What are that elements are there? No, that electrode, that what are their outer body or the shell. Okay, that means uh, preventing element from that overheating. It is called the total. It is called the torch. So in the plasma machining system, the torch is the important element. So we are going to discuss that point also later. And there will not be any contact between your workpiece and your that plasma. Sorry, not flame, plasma. That heating of the tungsten, that means rising temperature. So you will ionize the your gas, plasma gas. And then you will get the plasma arc. And then you can uh, target your workpiece. And then material removal will start. Okay. So I think you got just the idea about the plasma arc combustion. Okay. So in the next lecture, we are going to talk about the plasma arc system. So one by one elements. Okay. What is the role of that torch and everything? Wait for 2 minutes. I will take the attendance. Okay. I have taken the attendance. No problem. Now you can leave this meeting. Here we'll stop. Okay. Thank you.
हॅलो सर.
हॅलो. हा बोला की.
सर ते स्प्रेडशीटवर
हॅलो.
तुम्ही नोट्स क्लास नोट्स
नोट्स
अपलोड
पाठवत की.
ते प्रिंटेड नोट्स आहेत बहुतेक.
माझ्या आहेत की त्यात.
क्लास नोट्स आहेत का? हॅलो. हॅलो सर. हॅलो सर. हॅलो.
हा. हॅलो.
हां
हॅलो.
सर. हां सर.
हा माझ्याच नोट्स पाहिजे. हा ओके ओके. मी माझ्याकडे आहेत नोट्स. मी स्कॅन करून ठेवतो, देतो, लिंक देतो. आहेत नोट्स आहेत.
हां सर चालते. हां क्लास नोट्स असले की म्हणजे पाहिजे ते वाचता येते. थँक्यू सर.